Hey guys, in this video we're going to take a look at angle measures inside and outside of circles. To start off with, the first type of angle measures that we could have is on the inside. And when you're looking at the interior angles, we've already talked about several. We've talked about the central angles and we've talked about the inscribed angles. But what about the ones that aren't a central angle or aren't an inscribed angle? Those are going to be called the interior angles. So when you're looking at these, there's a couple different options of interior angles that we could have, and you use they come in pairs and you use them. You can use one pair or the other to be able to solve. So let's say they ask for angle ACD, or they ask for angle BCE. And the reason why it works for either, this rule is going to work for both of those, is because those angles are vertical angles. Remember, vertical angles are congruent. So when you have interior angles in a circle, their measure is going to be 1/2, so it's going to be equal to 1/2 the sum of their intercepted arcs. And remember, when you're looking at intercepted arcs, those are the ones that the angles, if you draw straight out and extend them all the way, those are the arcs that are inside of that angle. So we're looking at ACD or BCE is going to be equal to 1/2 of arc AD plus arc BE. Well, those aren't the only angles that we have on the inside. We also have angle ACB, so that angle right there. And we also have angle DCE, that angle right there. Those two are vertical angles, so we're going to write a rule for that one. So we're looking at angle ACB or angle DCE is going to be equal to 1/2 the sum of the intercepted arcs. So the intercepted arc for ACB is going to be arc AB. So we're going to do 1/2 of arc AB plus DE, arc DE, and that's going to give us the measure for either angle DCE or ACB. Looking at the next type that we could have exterior angles with our circles. An exterior angle are 1/2 the difference of the intercepted arcs. So looking at these, there's lots of different ways that they could draw lines with the circles. With this one, we had two secants where they intersected on the inside. With this one, we have two secants that intersect on the outside. So this, a lot of people will refer to this as secant-secant. So whenever you have two secants and they intersect outside, and that's kind of going to be the really big divide between the two different types of things that you could be solving for. Interior, you're going to be doing adding, and then exterior, you're going to be subtracting. So the big thing is some adding for interior, and then for exterior, you're going to be doing the difference, or you're going to be subtracting. So if we do the formula for this, and whenever you subtract, order matters, whereas with adding, it didn't matter which one went where. But whenever you're subtracting, you've got to do the bigger arc minus the smaller arc. So with this problem, they would ask you about angle QMR. QMR is going to be equal to 1/2 of the larger arc, so you've got to do large arc minus the small arc. So the name of the large arc for this one is going to be QR minus NP. So the measure of QMR is going to be equal to 1/2 of QR minus NP. So looking at the next one, this one we've got a secant and we've got a tangent. So they'll call this secant tangent or tangent secant. And it still applies the same rule. Angle, in this one we're going QSP. And it doesn't just have to be named by those values there. They could go TSR, TSP, QSR, just as long as they're naming and this is the vertex, this rule applies. So we've got secant tangent, they're intersecting on the outside. QSP is going to be equal to 1/2 of, we're still doing that large arc minus small arc, of QR minus RT. And that'll give us the values for those. Looking at this one is, it's a chord with a tangent. So with these, it doesn't have the two arcs intersected, where with these, there definitely was the two arcs that were intersected. We had that arc right there and that arc there, and then this arc there and that arc there. But with this one, we don't have the two different arcs, but we still use the intercepted arc rule. We're still doing angle BDE is the one that they could ask you about. So they could ask you about BDE, that angle right there. They could ask you about that angle right there and that angle there. And BDE is going to be equal to 1/2 of this whole arc that you see right there. So this whole arc right here, it's going to be half of that whole arc. So 1/2 of arc BZD, or you can just do arc BD for that one. So to go back through, it's going to be that arc minus this arc, and then big arc minus small arc. And then looking at this last one. This last one's a little bit different. This one is tangent, tangent. And it works a little bit different. And before I can tell you that, I've got to tell you about the tangent circle theorem. When you're looking at a tangent circle theorem, you're looking at a line drawn tangent. So this line right here will go AB to a circle. So line drawn tangent, line AB is drawn tangent to circle, let's go P. It's going to be perpendicular to a radius of the circle drawn to the point of tangency, and let's call that C. So that's the tangent circle theorem. Whenever you get two tangents together, you're going to have this right here. And so there's a 90-degree angle right there. There's a 90-degree angle right there. So what we have here is this type of a circle doesn't follow the same rules. And I'm going to go through a real quick of, just in case you forget how the value for what to use, how you can remember. Other than that, it's just remembering the rule. So if you look right here, we've got a quadrilateral. And from what we talked about, the interior angles of a quadrilateral, they're going to add up to be 360 degrees. But we already have two angles that are 90 degrees. So the 90 plus the 90 is going to be 180. So if we subtract those two, we have 180 degrees left. So between this angle right here and that angle right there, they're going to be equal to 180 degrees. And usually whenever you get these types of problems, they're going to give you the value for this arc right here. And that's where our rules for our central angles come in. This angle is going to be equal to that angle. So if we know that these two angles add up to be 180, then if they give you this one, they've got to add up to be 180 degrees as well. So pretty much to get this angle, so, and I'm going to write it over here on this paper so we've got it, the rules all together. If we want angle V, let's go name it the same way, AYB, that's going to be equal to 180 degrees because of what we just got done talking about with the quadrilateral, minus the arc VX. So whatever they give you there, it's going to be minus that. And if they ask you to solve for different parts, like if they ask you to solve for an arc, you just plug in the angle and then do the math to solve. So VX, there's the VX there that it gives you, and they would be asking for this angle right here. So what this section is looking at is lots of different ways to solve for an angle that's inside or outside of a circle, and I'm going to go through and show you a bunch of different examples. These cover most of the ways that they could have you do these circles. It doesn't cover all. If we tried to do all, we'd be here for a while. So we're just going to stick to the ones that we have here. Looking at the first example, the first thing you have to do with these is decide whether you're going to have interior or exterior. So if you're looking at how to do these problems and you like having steps, the first thing you want to decide is, are you interior or exterior? And remember, if it's an interior angle, according to our interior angle of a circle theorem, it says sum. We're going to be adding. So if it's interior, you're going to be adding. If it's exterior, you're going to be subtracting. And then from there, I mean, if it's interior, you just add them and go on. But if it's exterior, you've got to decide whether you're doing the 1/2 or you're doing the 180 minus. Or if it's just a regular and you're doing large minus small times 1/2. And we'll talk about those here in a second. But to start off with, I have a bunch of interior angles. So the interior angle theorem says it's going to be equal, the angle is going to be equal to 1/2 the sum of the intercepted arcs. So here's the arc that it wants us to find, because it says find the measure of the arc or angle indicated by question mark or solve for x. So this one has a question mark in it, so it wants us to solve for that angle there. So if we look at that angle there, the intercepted arc is going to be this one right here and that arc right there. So if we write the rule, our angle RPQ is going to be equal to 1/2 times arc RQ plus arc SA. And whenever you start doing these, I strongly suggest, like, whenever you do these, I want you to be writing the rules. I want you to write, okay, this is the angle it wants me to find. I'm going to do 1/2 of this arc there and that arc there. It's really good practice to help get into your head what values go where and remembering which formula goes to which problem to solve. So write the rules. And then once you get the rule written for the problem, then go ahead and plug the values in and solve. So we're looking for angle RPQ is going to be equal to 1/2. RQ is 175. Plus SA is 55, so 175 plus 55 is 230, and we're going to take 1/2 of that, and that's going to give us our value of angle RPQ. So 1/2 of 230 is going to be 115 is angle RPQ. So that's how you find the angle. But like I was telling you earlier, they could give you problems where they give you the value of the angle and they want you to find the arcs. And this is where writing the rule is going to come in very handy and help you out a whole bunch. So you're thinking that, is it interior or exterior? It's interior, so that means you're going to do the angle. And in this case, the angle that we're working with is UST. The way we know it's UST, it's the one with the angle measure in it. So we're looking at angle UST is going to be equal to 1/2, and using that definition still, it's going to be 1/2 the intercepted arc. So there's one intercepted arc there, and if we extend there, there's the other intercepted arc there. So we're looking half of arc TU plus, because we're on the inside, arc VA is going to give us the measure of our angle. So angle UST, we already know. They gave us the value in the problem. So angle UST is going to be 120, is going to be equal to half of TU is the one we don't know. I'm going to leave it TU. Plus VA is 60. So now we need to solve for TU. We've got that 1/2 there on that side, and I don't want to distribute and have a bunch of fractions everywhere. And the way we have it so that the fraction's not there, we can either multiply or divide both sides by a number. And I was going to multiply, but let's go ahead and just divide both sides by 1/2. So take 120 and divide it by 1/2. And you get 240 is going to be equal to arc TU plus 60. Subtract the 60 from both sides, and we get arc TU is going to be equal to 180 degrees. So not only could they give you an arc, give you a value for an arc and a side and ask you to solve for an arc, they could also give you algebraic expressions too. And then again, this is where if you use the rule the way you're supposed to and you write it out, it's going to help you a whole bunch. So if I'm looking and finding the values we're working with, we're on the inside, so we're interior, so we're going to be adding, which means I need to find the value of the two intercepted arcs in order to be able to solve. So there's the angle right there that they're working with. I know that because that's the angle measure they give us. I extend the lines. There's one intercepted arc, and then there's the other intercepted arc. So we're looking at angle RPQ is going to be equal to 1/2 of arc SC plus arc RQ. RQP is 120, or sorry, RPQ is 124, is going to be equal to half of 9x minus 3 plus 197. So I'm going to simplify some things first. 124 is going to be equal to 1/2 of 9x, and then negative 3 plus 197 is going to be 194. And then again, there's that 1/2. It's being multiplied to the parentheses, so we're going to divide both sides by 1/2, and that's going to give us 248 is going to be equal to 9x plus 194. Our goal is to solve for x because we're either solving for question mark or solving for x. So to get x all by itself, we've got to subtract the 194 from both sides. 9x is going to be 54. Divide both sides by 9. And x is going to be equal to 6. But be very careful because they could give you problems where they have you solve all the way through, and then they ask you a question like, find the measure of angle QPR. So then you've got to go through the process of finding x, and then once you find x, take it and plug it back into whatever value they're wanting you to find. So looking at this example right here, that's exactly what they're doing. So if we're looking, and they don't give us just an angle measure here, they give us an expression. So again, this is where writing those rules come in so handy, and they're so important. That's the angle we're working with. We know that because that's the value that they gave us. If we extend those out, that will give us our intercepted arcs. So now that I've found all the pieces I'm working with, I'm going to write out the rule. So using the interior angles of a circle theorem, the interior angle RPQ is going to be equal to 1/2 of the intercepted arc. So intercepted arc is RQ plus arc SV. So angle RPQ, looking at that picture, we know it is 26x minus 2 is going to be equal to 1/2 times RQ has a value of 131 plus the other arc SV, 18x plus 1. So if we simplify things, 26x minus 2 is going to be equal to 1/2 times 1 plus 131 is 132 plus 18x. And since both of those numbers are even, we can distribute this, or if you want to, you can divide both sides by 1/2 just like we did up here. I'm going to distribute it to make the numbers smaller to work with, because if you divide both sides by 1/2, you're going to make the numbers bigger. So 26x minus 2 is going to be equal to 132 divided by 2 is 66 plus 18 divided by 2 is 9. So continuing to solve our algebraic equation, minus 9x both sides. It's going to give us 17x minus 2 is going to be equal to 66. Add the 2 to both sides. 17x is going to be equal to 68 divided by 17. And then x is going to be equal to 4. And this is what I was telling you about. Don't get down to x equals and be like, okay, done. Because this one specifically says find the measure of angle QPR. And if you do that, QPR is equal to 26x minus 2. So the measure of angle QPR is going to be equal to 26 times 4 minus 2. 26 times 4 is going to be 104 minus 2 is 102. So the measure of angle QPR is going to be equal to 102 degrees. So that's a pretty good look at the different types of interior angle problems that they could give you to solve for. The rest that we're going to work with today is going to be the exterior angles, because we already did so much in the last lesson working with the central angles and the inscribed angles. The only thing we really had left to talk about was these. Well, we haven't talked about anything exterior, and that's why there's so much more exterior than interior. Okay, so whenever you're looking at exterior, the big thing is you're going to have to decide whether you have 2 intercepted arcs that you can subtract, or if you only have 1 intercepted arc that you're going to take the half of, or if you have 2 tangents, and then that means you're going to subtract the 180. And for this one, if you have trouble, I would suggest leaving the picture of the rules right beside your homework as you do it to help you match it up a lot easier. So if we look at this first example that we have here, we have 2, that looks like a secant and a secant. So there's secant and secant there. So this one is a secant, secant. Okay, so it's an exterior angle, so that means we got to match it to one of those there. So that makes it secant, secant. So that means that the exterior angle, and in this case it's angle FRT, and that's going to be equal to, remember, the rule says up here, it says large arc minus small arc. So if we're looking, here's our angle. And if we extend those angles all the way out, that does our intercepted arcs for us. So there's our larger arc, and there's our smaller arc. So our larger arc is FT, and since we're exterior, we're going to be subtracting QS. So FRT is the one we don't know. I'm going to leave it FRT. Is going to be equal to FT, which is 140, minus FT, minus QS, which is 50. So angle FRT is going to be equal to 90 degrees. So that's an example of just how you use the definition exactly as it's written. So looking at the next one we have an exterior angle, and looking at this line, that's a secant, and that one's a secant, so we're going to use our secant rules again. And using our secant rules, we're going to have the exterior angle is going to be equal to half of the large arc minus the small intercepted arc. So if we outline everything that we have, there's the angle we're working with. Here's our large arc. There's our small arc. So we're going to do angle PRD is going to be equal to 1/2 of arc PD minus, because we're outside. Anytime you're outside, it's always going to be minus. And then the small arc is QS. So PRD, they do give us this value. It's 50, is going to be equal to 1/2 of PD is 12x plus 8 minus, and it's this whole value of arc QS. So we've got to put the whole thing in parentheses. So 4x plus 4, close the parentheses. So I'm going to start simplifying things inside the parentheses before I do anything else. The first thing I'm going to do is distribute this negative to everything on the inside. So 12x plus 8 minus 4x minus 4. So 50 is going to be equal to 1/2. 12, combine our like terms. 12x minus 4 is going to be 8x. And then positive 8 minus 4 is going to be a positive 4. So now at this point we have this 1/2. We can either divide both sides by 1/2 or distribute the 1/2 inside the parentheses. Since both of those are even, I'm going to distribute the 1/2 to make the number smaller. 50 is going to be equal to 1/2 times 8 is 4x plus 1/2 of 4 is 2. Still continuing to solve for x, so subtract 2 from both sides. And then 48 is going to be equal to 4x. Divide both sides by 4. And then x is going to be equal to 12. And I'm just double checking up here to make sure that they didn't ask us to solve for anything else up here. Like this one asked for angle QPR. I'm just double checking. I don't need to substitute the x back in to find either arc QS or arc PD. And they didn't. So this one's good to go. Alrighty, looking at the next one. Oh, looking at this one right here. I just found a mistake. Go back and fix it right now. Write it with me. I should have done half of it. So for right here, I should have done half of 140 minus 50. So for angle FRT is going to be equal to 1/2 of 90. So angle FRT is going to be equal to 45 degrees. There we go. Hopefully you were fussing at me going, no, wait, I thought you said it always had to be 1/2. Yep. You're right. Okay, double checking the rest of them. I think we're doing okay on the rest of them. 1, 2, 45, 12. Okay, yeah, we're doing good. All right, so looking at this one. Interior angle or exterior angle? We have an exterior angle, so we're going to be subtracting. Probably going to be subtracting. but just to double check, I'm going to line it up. This one isn't a secant because this one touches just once on the outside. So this one is our secant tangent that we're working with. My problem got a little long. So that one right here, I'm going to do over there. This is going to be secant tangent. So when we're doing the secant tangent, we're still able to use that rule of half of the big angle minus, or half of the big arc minus the small arc will give us the angle that we're looking for. So I'm going to write the rule for this problem right here. Angle CEF is going to be equal to 1/2 of the bigger arc. There's one intercepted arc, there's the other. So half of CF minus FD will give us the measure of that angle that we're looking for. So angle CEF is going to be equal to 1/2 times CF has a measure of 195 minus FD is 75. So angle CEF is going to be equal to 1/2 of 195 minus 75 is going to give us 120. So half of 120 is going to be 60. So CEF is going to be equal to 60 degrees. Looking at the next one. There's our angle that we're looking for right there. We've got another secant tangent. So we're looking at angle, this one right here, secant tangent. Our angle is going to be equal to half of the large intercepted arc minus half of the small. So angle PRS is going to be equal to 1/2 of PS is the large arc minus QS is the small arc. So 44 is going to be equal to 1/2 of PS is the one we don't know, so I'm going to leave it arc PS minus QS is 65. So we're wanting to solve for PS, and if we distribute that 1/2, we're going to have a bunch of fractions everywhere. So this is a good one to divide both sides by 1/2. And if we divide both sides by 1/2, we're going to end up with 88 is going to be equal to arc PS minus 65. Add the 65 to both sides, and then arc PS is going to be equal to 88 plus 65 is going to be 23 degrees. But that can't be that because that's the big arc. Oh, I subtracted them in my calculator instead of adding them. So 88 plus 65, try one more time, and that's going to be 153 degrees. Makes a lot more sense for the big arc to be more than the littler arc. Okay, so there's your those. Looking at the next group, I told you there was a lot of these, but I wanted to make sure I could get as many as I could with you. So looking at these, we've got another secant tangent. So there's the secant tangent. So using the secant tangent rule, I've got angle MKJ is going to be equal to 1/2 of the large intercepted arc, which is MJ, minus the smaller intercepted arc, which is LJ. So they tell us MKJ, 50 degrees, is going to be equal to 1/2 of MJ is 19x plus 13 minus, and don't forget to put this in parentheses, 8x plus 1. So 50 is going to be equal to 1/2. I'm going to distribute that negative first. 19x plus 13 minus 8x minus 1. So 50 is going to be equal to 1/2. 19 minus 8x is going to be 11x. 13 minus 1 is going to be a positive 12. So we could distribute the 1/2 or divide both sides by 1/2. I'm going to divide both sides by 1/2. 100 is going to be equal to 11x plus 12 minus the 12 from both sides. Gives us 88 is going to be equal to 11x. Divide both sides by 11, and x is going to be equal to 8. Alrighty, looking at the next one, this is another example of be careful and watch what they're asking you to solve for, and don't just assume that they want the variable. So I think this is our last secant. This was a secant tangent. And this one is our last secant tangent. Okay, so looking at the secant tangent, there's the secant. There's the tangent. There's our large intercepted arc, and there's our small intercepted arc. And the angle is on the outside, so we're going to be subtracting. Angle CDF is going to be equal to 1/2 times the large arc, CF, minus the small arc, EC. So CDF has a measure of 30x is going to be equal to 1/2 of CF is 118x minus 1 minus 57. So 30x is going to be equal to 1/2 of 118x. Negative 1 minus 57 is going to give us negative 58. So then 30x is going to be equal to, I'm going to distribute that 1/2. So 58 divided by 2 is negative 29. 118 divided by 2 is going to be 59. Subtract the 59x from both sides. So 30 minus 59 is going to give us negative 29x is going to be equal to negative 29. Divide both sides by the negative 29. And x is going to be equal to 1, but we're not done because they want FC. The measure of arc FC is going to be equal to 118x minus 1. So the measure of arc FC is going to be equal to 118 times 1 minus 1. So we've got 118 minus 1, which is 117, and that's going to be our measure of arc FC. So there's that one. Looking at the next one, this one is it's kind of a gray area. It looks like it's interior, but it doesn't have the two intercepted arcs, but it's got this little bit that's on the outside, so it's a little mixture of both. So that's why it's not the same exact large arc minus small arc, besides that it doesn't have a large arc. It does still, since it's kind of a little bit of both, I guess that's why it's still the 1/2. So if we're looking at these are called chord tangents. They could also honestly be secant tangent, depending on how they're drawn, but it's going to be with a point on the side for the tangent. So looking at this one, there's our secant, there's our tangent, or our chord and our tangent. So we've got to focus on what we're trying to solve. So there's the angle right there that we're focusing on. We know that we want to focus on that because they put a big old question mark in there. Another way for them to do it is to put an angle measure in there. So if we're looking at this one, here's the intercepted arc. So you're going to want to write the rule because they're going to give you problems with equations in them too. So angle KLM, and I'm using this rule that we have up here, is going to be equal to 1/2 of that intercepted arc. And I did use 3 letters there. You don't have to use the 3 letters to name the arc. If they only give you 2, it's okay. KL. So angle KLM is going to be equal to 1/2 times 130 degrees. So half of 130 is going to be equal to 65. So angle KLM is going to be equal to 65 degrees. Looking at the next one, it's kind of the mixture of both, the secant tangent or the chord tangent. And it's the mixture of the both being inside and outside, and plus there's only one intercepted arc. So if we do this one, we're going to look at angle FED is going to be equal to 1/2 of the intercepted arc ED. So angle FED is in the question marks here, so that means we're going to want to solve for that one. FED is 75, is going to be equal to 1/2 times arc ED, which we don't know, so I'm going to leave arc ED. So ED isn't all by itself on one side, the equal sign, so divide both sides by 1/2, so 75 divided by 1/2 is going to give us 150 degrees is the measure of arc ED. So looking at the next problem they give us, in this next problem, it's interior, but it's not, and there's only one intercepted arc, so that matches up with this one right here. So we're looking at the measure of angle ABC is going to be equal to 1/2 of the intercepted arc AB. So if we look, they tell us that the measure of angle ABC is 10x minus 10, so we're going to substitute that in, is going to be equal to 1/2 of the intercepted arc AB is equal to 15x plus 15. So we could distribute, but we're going to end up with fractions or decimals, so I'm just going to divide both sides by 1/2. So 10x minus 10, you've got to do both of them. So 10x minus 10, 10 divided by 1/2 is going to be 20x minus 20 is going to be equal to 15x plus 15. I'm just going to go through and solve for x minus the 15 both sides. That's going to leave us with 5x minus 20 is going to be equal to 15. Add the 20 to both sides. 5x is going to be equal to 35. Divide both sides by 5. And x is going to be equal to 7. And this is the part that I'm going to warn you. Don't always assume that they just want x, because this is one where they say find the measure of angle ABC. And the measure of angle ABC is equal to 10x minus 10. So the measure of angle ABC is going to be equal to 10 times 7 minus 10. So 10 times 7 is 70 minus 10, which is going to be 60. And that's our measure of angle ABC. All right, so that covers all the chord tangents or secant tangents where the angle is on the vertex. Looking at the last one, these are the tangent tangents. And the tangent tangent can look like this, where they have a line there and a line there that goes on forever. And they can also look like these, where they stop right on the edge of the circle. And a lot of times with these in the directions, it'll say if the line appears to be tangent in the picture, you can assume that it's going to be tangent. Not very often you can assume things when you're looking at stuff, but if they tell you that you can, then it's okay. So looking at this one's a tangent tangent. And this is, hopefully this is another point where it's a red flag and you see that there's only one truly intercepted arc with what you're working with, that they have a value for right there. So with this one, this is going to be the one where the measure of that angle, so in this case the angle is RQP, is going to be equal to 180 minus your intercepted arc RP. And it's the one on the inside that's closest to it, or opposite of it. So in this case, angle RQP is going to be equal to 180 minus 120 degrees. So that's going to be angle RQP is going to be equal to 60 degrees. Looking at the next one, 2 more to go. Looking at this one, There's our angle that we're looking for out there. It's on the outside, so it falls under our exterior angle rules. That problem got a little out of control. So we're looking at angle FED is going to be equal to 180. And this is our tangent. And this one up here, and I forgot to label it. Don't forget to go back and label it. Tangent. So with this one, FED is going to be equal to 180 minus the intercepted arc that's closest. So minus FD. So angle FED is 50 is going to be equal to 180 minus arc FD. So I'm going to subtract the 180 from both sides. So 50 minus 180 is going to give us negative 130 is going to be equal to negative arc FD, but we don't want to know what negative FD is, so divide both sides by the negative 1, and arc FD is going to be equal to 130 degrees. And last one, woohoo! So there's that angle that we're working with right there. Those two lines are tangent and another tangent. And this is another example of a problem where writing down the rule is going to help you a whole bunch. Angle LKJ is going to be equal to 180 minus that intercepted arc LJ. So we've got 70 degrees is going to be equal to 180 minus, and it's all one phrase, 27x plus 2 in parentheses. So 70 degrees is going to be equal to 180 minus 27x minus 2. So 70 is going to be equal to 180 minus 2 is 172 minus 27x. I want the x by itself, so I'm wanting to move this guy away. Subtract the 172 from both sides. So 70 minus 172 is negative 100 is going to be equal to negative 27x. Nope, 70 minus 172. It's going to be 102. So divide both sides by 27. And that still doesn't give me the right answer. What did I do? 27 plus 2, 180, 70. Is that kind? 178. So 70 minus 178 is negative 108. Divide both sides by 27 now, or negative 27. Yeah, there we go. And then x is going to be equal to 4. And I'm double checking to make sure it didn't ask for LJ. So the answer for this one is going to be x is equal to 4. So we got a lot done today. Looking at what they had us do, we did the interior angles of a circle theorem. We did all those. Remember, when it's on the inside, you should be adding those two intercepted arcs together. Whenever it's on the outside, that's where you're going to be subtracting. So looking at our secants that we did, I think we only did 2, yeah. Looking at our secants, that's where it's the large arc minus the small arc times 1/2. And then looking at our secant tangents are where you're going to have, it's still the 1/2 times the large arc minus the small arc. So I showed you a bunch of secant tangents. Oh, and I didn't label these. Make sure you label these. This is a, I'm going to go with chord tangent. Or you could go, I'm going to name it a chord secant tangent, just so we can tell the difference from the others, because it is different. Chord secant tangent. And this one is a chord secant tangent. and then we did our tangents. If you have any questions left over from any of the examples that we did or any of the ideas behind how these work, make sure you write them down and ask whenever you get to class.